So welcome back, everyone, for the last talk for today. It's quite a little bit sad every time I have to announce the last talk. I know the day is over. But on the other hand, you have more time to talk afterwards on the socializing event, I say. So today, Carsten will be the last speaker. And he has brought a topic that last year he actually talked about in another fashion. And a year goes by and some things evolve. And so now we kind of get an update about what's called sustainable applications. So give it up for Carsten.
Thank you. Thank you. Thank you. Okay, yeah, last spot of the day is always a bit challenging, but I'm happy to see so many faces. Let's get this started, right? So, yeah, sustainable software, what does it mean? For me, it's, I made it green, right? So this is, I hope it's clear, it's about the ecological aspects of software. And I'm not sure how many of you are ever wondered, does my software actually cause CO2 emissions? I mean, that's a question, at least from my experience, not many people ask themselves, which is kind of not surprising when you see a laptop like this here. Maybe it's super clean, right? There's nothing coming out of it. It's nice, but you don't see the things that actually are necessary to produce such a device, to get the resources out of the ground, to transport it around the world, and of course, for the electricity. And I think if these machines would... No, it's gone. Aha. And I think if these machines would emit fumes, like, I mean, if it would do now, it would be really a problem. But if we would see what it would cause, and it would fill the air here in the room with all the emissions, then I think we would be think a bit differently, right? And that's actually what we are doing with our lovely planet, right? We are emitting carbon into the atmosphere like there's no tomorrow, and that's why things are getting a bit hot in here, for example, or in our atmosphere. Okay, so maybe that's one of the reasons why this famous Gartner Institute, these people who always claim from themselves that they can estimate trends in the future, or they can predict trends, they put sustainable technology also one of the core trends of 2024. That made me happy, of course. If you are not so much into this topic, maybe you don't really care about it, maybe still I have some other things which could make you more interested in this topic, because sustainable software can lead to happy customers, it can lead to happy managers, it can also lead to happy developers. So actually this is one thing, that's actually one thing which we all hopefully want, right? So even if you don't really are into this carbon stuff, bear with me, there will be other things. Okay, so my agenda for today is actually, let's start with how to measure emissions. We can only optimize what you measure, you know this thingy, this quote. Then I will talk about sustainable software in a nutshell. Really, I don't have that much time. I could talk about this for hours probably. I will try to keep it very short. And lastly, we will do a bit of PHP where we start optimizing some code because, yeah, it's a developer day after all. But let's start with the first part, how to measure emissions. This is one thing. As I said, there's nothing coming out of this machine directly. And there are a lot of smart people, not me, but other smart people, no, other people, let's say, who started thinking about this problem. And they started quite basically. They started with the old desktop computers, right? For the younger people here, this is how these things look like back in the days. And what they did, they took a desktop computer, they ran the software they wanted to test on it, and they put I think that's called a watt meter or power meter or something, between the wall socket and the computer. And that worked. So they could, of course, you have to do it very strict. You have to make sure that no other processes are running, etc. So that's quite a difficult setup. But this is how they did it. And then they could measure the energy consumption. And when you have the energy consumption, we have the tools nowadays to say, okay, this is here, for example, the carbon intensity. So we know from the past and for the moment, we have the data sources for that. We can say, okay, at that time, 2 days ago, around 1 o'clock, the carbon intensity was 180 grams per kilowatt hour, so means 180 grams of carbon per kilowatt hour. You can see that this varies greatly, right? At night, there's not so much sunshine. This is a problem which we still have to solve. But this is at least something which we can use. Okay, we have the consumption, we have the carbon intensity, but this is unfortunately not everything, because there's more to it. As I said, these devices also need to be manufactured. And you can see it here. The share, this is like, this is the average emissions from a device like a laptop, for example, around about 100 kilograms of carbon per year if you use it for 5 years, let's say. This is the emissions this will cause. And you will see that the vast majority of the emissions is from the production. Yeah? And only the little bit is from the energy consumption. So these machines, I mean, I could run this thing the whole day with just one load of battery. This is quite cool nowadays, so they're super efficient. The problem is more that we have so many of them. And then there's, of course, more problems. I mean, we are web developers, right? So usually our software does not run on one machine. I guess that's true for most of us here. The internet is a big thing. You cannot just measure the emissions of the internet. It's not possible. You cannot get all the data. This is just impossible. So what can you do? Again, these smart people started thinking about the problem, and they came up with the first tools. This is the website Carbon Calculator. This is one of the first tools of its kind. The people said, okay, we have a website, we get some information from that website, and we use this information to estimate carbon emissions. And this is a very important point. When I sometimes say measure or calculate, it's always some kind of estimation, because we cannot know for sure. I will show this in a minute. So this is for the website cnn.com. This is very small in the top. You can see this website is pretty bad. So even worse than the global average. So 2 grams of carbon per website view sounds not so much. But when you think about that, this website has 1 billion views per month. You can do the math, and you will end up with a lot of carbon emissions over the year, just for one website. And yeah, exactly. So how do they estimate that now? So there's the so-called sustainable web design model, which these people came up with. It's basically a handy formula which you can take. I will not go through this, but there are some factors in there, like OP is the operational the emissions from the operation network, NUD is user device. Then you have the embodied carbon. This is the carbon which gets, which is already in this device just by producing it, right? So what has been emitted during the production phase. Then if this thing is hosted on a green hoster, there's a database which you can use to query and find out if your hosting is green, which is cool. Green means renewable energy and these kind of things. So in the end, it's just, I always think of it, it's a guess. So you take the data transfer, the carbon intensity, you multiply it with a couple of factors, and then you have your emissions. It's something, but it's not super accurate. Because, for example, maybe the website, is it now a statically hosted website, or is it maybe with a CMS behind it? Is the CMS, let's say, pretty fast, or is it very inefficient? So is the caching good or not? I don't know. There's so many factors which, of course, this website Carbon Calculator cannot know. So just take all these numbers, although they look very accurate. 2.818 sounds like, yeah, super accurate. It's not. Luckily, there are more tools for that, which you can use. And I played around with a couple in the recent weeks and months. One of it I found pretty handy, especially for us developers, is so-called GreenFrame. It's basically a tool which you can install on your local machine, and it will use your local Docker installation. So you need to have a containerized application, of course, but it will use the information that it gets from Docker, from the Docker daemon, to calculate emissions. It's really fancy. And I will show this a bit later again. There's another tool which we use in our company as well. It's the so-called Cloud Carbon Footprint. This is a tool where you say, when you run software in the cloud, you can get all the usage information from an API. So you can immediately fetch all the data. you need, and this tool will again use some so-called emission factors to calculate the emissions from that. This is a screenshot from their website. This is not our emissions. Yeah, so, but this is not really good for developing, for software development. This is more for infrastructure optimization. But for that, it's very good. I was really happy to find that GitHub itself released just a couple of days ago the Green Software Directory. So it's a repository, an official GitHub repository, which lists a lot of cool tools. There's already quite a lot. Also these two, which I just mentioned to you. I find it super fascinating, and I'm super thrilled that GitHub is taking also more steps on that. Let's see what comes there. Okay, so now we have the way to at least measure emissions. Let's say estimate. I think it's not always so important if it's 1 or 1.5 grams, but it's good to know the relations when you do some optimization and you have a before and an afterwards. So these tools are quite good. So let's start. I usually organize the sustainable software approach in some levels. Think of it of level 1 being the probably easiest to achieve with the highest impact. So the probability that you get some really cool shit out of this is quite high. Then architecture, software architecture, for me that's how components of our software play together. This is another level which you can achieve. Then the next level would be code. So of course, there will always be, maybe if your code is super bad, let's say, you can achieve more, of course. But from my experience working on this field, this code comes at this point. And then there's another level which is called carbon awareness. And this is a feature, it's a topic which I will just show you very briefly because it's highly experimental at the moment. So this is why it's at the last level. So for the infrastructure, if you want to optimize your infrastructure in an ecological way, of course, first thing is really, and this sounds like a no-brainer, and I'm always like, yeah, of course, but turn off unnecessary resources. You hopefully turn off the light when you leave the room, right? So, but this is not what happens on many cloud environments. So then you have maybe some instance running because you don't know, is it still in use? Is it not? What happens when I turn it off? Maybe somebody will complain. So you leave it running, what can happen? The thing is that a resource, a server which is running, even if it's idling around, it still consumes a lot of energy because you have this baseline for the net, for the power adapter, for the memory and everything, which consumes a lot of energy. So maybe some of you even have this notorious server in the back of your office which runs the whole year, and just once or twice a month it does a cron job, and then it's again idling. So these are the things which we should really take care of. Right sizing is another approach which also is very promising. So when you have a resource, usually when you start with a new project, you just give it a nice big instance because you want to go sure. But at some point, you should really try to optimize the size of that instance. Means how many CPU cores does it get? How much memory will it have? And there are even tools from AWS, for example, which help you with that. They will try to help you. I'm not sure how much I can trust AWS, let's say, but they will give you some tips, some hints which instances can be right-sized. Of course, when you right-size an instance or some system, you will not have that much buffer anymore. So if there are peaks in your daily, I don't know, you have a web shop and you usually have some peaks there. This is what we then call dynamic resource allocation. Means some surely know it as auto-scaling, right? So when you have a cluster with some nodes, if the demand gets higher, you will automatically add some nodes. If the demand goes down, you will remove the nodes again. Also, this for me sounds like a no-brainer, but again, a lot of companies which I talked to, they were kind of a bit surprised that this is actually something. So, I don't know. Storage and data retention is also very important to take care that you don't upload everything which you have into the cloud. So everybody has their smartphones in your holidays. You upload your 4,000 photos into the cloud, and usually they stay there. You will never look at them again. And this sounds like, okay, it's out of our mind, but the thing is, think of these, they have to be eventually stored on some hard drive, in some server, in some data center. So the more stuff we upload to the cloud, the more servers we just need to keep this data alive, which we actually don't need anymore. And these are the things which you can also, in the cloud, you can use data retention. You can say, I don't know, logs can be deleted after 1 year, or temporary file uploads can be deleted automatically after 3 months, or things like that. So there's a lot which you can do. We applied in our company a couple of these topics which I just mentioned, and we were kind of surprised how much we got out of it. So you can see here, this is from the Cloud Carbon Footprint tool. You see 3 curves. The blue one is carbon, the yellow one is energy, and the green one is cost. Not surprising that these 3 are closely related. And just after a bit of work, we were able to reduce our emissions and our costs by 70%, just because we found a lot of things where we said, okay, auto-scaling was not set up correctly, some instances were way too big, we even had a full cluster flying around in the cloud which was not used anymore. This happens, right? Okay, so now some of you might think, okay, wait, this is DevOps stuff, right? What he's talking about is just normal DevOps stuff, and this is partly right. So there's this discipline called FinOps, for example. These people try to reduce the costs of the cloud as much as possible. And there's quite some overlap to a discipline which we call GreenOps. These are the people who try to reduce emissions as much as possible. And there's actually a win-win zone, if you like, between those 2 fields, because whenever the FinOps, they manage to reduce stuff, or not always, but often when they reduce costs, they will also reduce emissions, which is quite nice. Okay, so this is the infrastructure. Let me check the time. Okay. Then second level would be architecture. First of all, some architecture principles which I would recommend is, one is the event-driven architecture. This is, when you compare this typical setup, you have, last year when I was here, I talked about this one web service we had in our company, which was constantly pulling data from another data source, every half an hour checking, has there been changes? No, okay, check in half an hour again. We exchanged that with event-driven approach, and this helped us reduce a lot of emissions and costs as well. So this could be also an approach, like this constant polling is really bad for your costs and everything. Then microservices and serverless. We heard this wonderful talk from one of the Sebastians today about microservices. Here also take it, not split up your whole application into super small microservices, rather extract those things which are really hard to scale, which really need proper scaling. If you have a monolith, for example, you cannot scale a full monolith so quickly, so well. But if you have one part of it which needs to react really fast, then you could offload this to a microservice, maybe even serverless, when then the cloud provider takes care of running your functions in the cloud. You don't have to keep any cluster running, and the idea behind that is that the hoster, the cloud provider, they can distribute the workload over their many servers much better. So the utilization of the old servers in the data centers is much higher. Caching, this is, because it's so hard, nobody does it, at least that's my impression, but it helps a lot. I know it's painful and it will require a lot of work and fine-tuning, but it's really helpful. And of course, the choice of programming languages or the tools in general. So if you have this one service which really requires full power, maybe consider writing it in a different language. I mean, PHP, after all, is not compiled. So we do have some drawbacks here. Yeah, of course, we should write PHP as much as possible, but maybe there are some little services. Okay, let's look at the code level. So we are driving a bit deeper now. Usually when you think about efficient code, you think about algorithms maybe, or big O notation. Yeah, how does this algorithm behave? To be honest, I never implement any algorithms during my daily life. I just write my typical CRUD stuff or whatnot. But if you really have to implement a search algorithm, okay, yeah, then you should take care. But other than that, I would recommend maybe start with the database. And it's really like that. If I would get €1 for every time a missing index is causing performance problems, I would be a rich man. But it's amazing. I think this has to do with that we are so decoupled nowadays from the database with ORMs and everything. Developers, when they talk to them and they say, I say, what about the index? And then they like, oh, index? Yeah, I don't know. That's a shame. So you can optimize a lot. Again, on the code level, also caching. In memory caching, just keep a result of some function. If you have a loop, keep the result in a variable. This can already help. So also think of that. And one thing which we also will see in a minute is I would actually really prefer native functions over any packages, libraries. I know this might trigger some people, but libraries and packages, choose them really carefully. If you have to, think about them, compare them maybe with others, do some runtime considerations, because yeah, we will see it later. And then, of course, when you are at that level, now we can start thinking about profiling and optimization. Before I get to that, just a very short dive into the carbon awareness. In a nutshell, it's basically you want to use the energy when it's the greenest. So during the day, we have a lot of sunshine mostly, and wind is blowing, let's say. The carbon intensity is low. So how about moving workloads from times where it's not so good into times when the when the carbon intensity is low? For example, I have my solar panels on the balcony, and what I do now when I'm working from home office, don't tell my boss, but I'm running the laundry during daytimes because I want to use the solar panels, of course. It doesn't help me when the energy goes into the grid. I want to use it now, and this is the concept of being carbon aware. Let's use the energy when it's there. Of course, this is kind of a different mindset, but yeah, why not? Why not think about it? Okay, so there are other approaches to carbon awareness, but this is the most important one. I will skip the others because now we want to finally get some coding done. I have, of course, a little code example. Since I'm working in a company, we do carbon accounting. That means that we get a lot of information from our customers. We calculate emissions out of that, and that's why we do a lot of a lot of data processing. So my example is pretty similar maybe to last year, but there's some changes. A CSV export. It's boring, I know, but it's one of the many things which we do. It doesn't matter if we export to CSV or somewhere else. This is just for demonstration purposes here. And really, as a disclaimer, I would not code like that. Yeah, please, don't do this. I see this a lot. This is the Laravel sickness, which I call it. That this is called artisanal or cool or elegant. It's not. It's shit. Yeah, let's not do. Okay, Laravel bashing always works, but we also do a little bit. So we use the Carbon library here. What I did, so I set up a Laravel sale application. I mean, I have to say the tools are awesome, yeah? When you want to do things like that, it's perfect. I set up a table, 50,000 rows, with some have the flag active, and the other have, like, as 25 have active, 25 inactive. That explains some numbers, which you will see in a minute. And yeah, I set up an endpoint, and this endpoint doesn't export. 450 milliseconds, like on my home computer at home here, my Linux machine, it doesn't matter really how much it is. And again, I would not do these kind of things, so I would do some asynchronous job when I do an export. I wouldn't do this like in a synchronous way, but this is just for demonstration purposes. And then I did a second one, which I called fast export. Yes, it's true, we developers are bad in naming things, so fast export will be the one which we will see after the optimization. The tools I used, Xdebug. Who of you uses Xdebug? Can I have? Oh, wow, this is cool. Nice. Because there was just this JetBrains survey where they found out that only 30% of people are using Xdebug, which I found super sad, but looks like PHP community here in Dresden rocks. Nice. So I use Xdebug not only for debugging, but also for profiling. Who of you uses profiling? Oh, also still a lot. OK, cool. Kcachegrind, I love this logo. It's so cool. But this tool is necessary. You need the tool to display the information from Xdebug Profiler. Otherwise, you will get super, super sick. This is a little tool that I should not complain about logos. This is my little tool I wrote just for my own purposes, actually, but I find it highly useful to compare code samples. So the execution time of code. You will see it also in a second. And then, in the end, we use green frame to get the emissions from it. OK. So this is the screenshot from Kcachegrind. This is probably the reason why many people don't use it, because I was first thinking, should I make a live demonstration here? You would not see so much. So I decided to go with cutting out some things. These beautiful maps here, they are in the first glance, they are very confusing. So this is now the view when I go into my controller, the controller I programmed here for this export, and I want to see what functions are called from that point on. So you see, for example, a lot, makes sense, right? A lot of eloquent stuff, I don't know. But also here, carbon there's a lot of carbon going on. I always find it so funny, the name. Fits so well for my purpose here, that's why I always use it. So the area which is used gives you an indication of how big the share on the runtime is. Maybe a better view is that one here. You get first in the left corner, left column, you see 50% of time, let's say, is used only for the eloquent model for the magic get functions. Wow, that's why I was a bit surprised about that. But you also see it's 75,000 function calls, because I have 3 times 25,000 data sets. And then you can also see, oh, sorry, this was the wrong one. Here, carbon, a lot of carbon happening here, roughly 10%. And that already gives me a good indication of where my problem lies. There's another view which you can use, of course, for those who don't know this tool. I'm sorry, so many. I didn't expect so many. This is not only super helpful if you have some performance problems, let's say you have maybe a loop in your code and you don't know where. This can really help you, this tree view. Otherwise, you will get the same information, just displayed a bit differently. You have on the left side the carbon, in the middle the eloquent builder, and on the right side the get, all this get-related stuff. One thing which I find really cool about Kcachegrind is that you can configure it to print information inside of the code. So you have then a view here. This is the little function which I wrote, and then you see it's a bit hard to see. Here, for example, for the first call, you see what other function has been called through this call, to this function call. And we also see here, for example, a lot here again where the whole get stuff happens just because I want to get this information from the object. All this happens just because of that. And the carbon create, you see here, it's a lot of, also a lot of stuff happening here. What I found very interesting is that the actual write operation is super tiny, right? So this seems to be very efficient, so I will not have a look at that. I will concentrate first on the big blocks, of course. Makes sense. So in my code sample here, I will look at this, and I will look at that. OK, cool. My little tool which I wrote, it's basically end time minus start time, just with a bit more comfort. You can just put it into everywhere. This is quite helpful because I can just put it into some function and let it run, and then it logs into the Laravel log, for example. So I compare here normal string concatenation with sprintf, and let it run for 1,000 times, get the average out of it, and I see that sprintf is 3.17 times slower than string concatenation. Okay. Again now, or not again, but think about if you just use it somewhere in your code, not in a very prominent position, not where it's executed a lot of times, forget about it. This doesn't really matter. But in my case, when I run this stuff in a loop, and I have it for a lot of data sets, then everything matters. And this is for PHP 8.3. I heard that PHP 8.4, there will be optimizations for the sprintf function, which I think Florian Engelhardt wrote that in his blog post. Oh, you wrote that. Ah, nice, cool. So this is outdated by now, but this is just, I didn't try it with 8.4. Cool, but luckily I knew that before you could correct me here. Nice. Okay, let's go. So my first step was, okay, if I saw somewhere that the constructor was heavily used from Carbon, so I extracted the constructor outside of the loop and just thought, okay, let's just use one instance, set the timestamp all over, and let's go. For some reason, I don't know, it was even slower. I looked into the Carbon code and stepped immediately back because I don't want, it was just too much. I just want to get some string formatted here. So why not replace Carbon with the good old date function? And what can I say? It's immediately faster, of course. And this is usually the time when the people in the audience get upset, when they want to beat me up afterwards because I question their belief systems. But this is what I'm trying to say. Maybe use functions which are already there. I mean, what's the benefit of having Carbon can do so much. This library is really amazing. But for my little use case, just because I know Carbon and I use it all the time, doesn't mean that there are not better alternatives. And when I compare it directly, you will see that this is, on my machine at least, this varies really on the machine where it runs. It's almost 8 times faster to use date instead of Carbon. So in this case, when I don't need the bells and whistles which Carbon can have, then it's cool to run this very light function. Then, of course, this is always the biggest fun for me. How about replacing an ORM with the good old SQL call? And yeah, what can I say? The whole thing is immediately much faster. This is not surprisingly, but still it is wonderful. And when I say, okay, maybe when we have performance critical parts in our code, maybe not use an ORM? And this is then the time when the people usually want to beat me up because I question their belief systems. But what can I say? I mean, it's like that. Okay. I can even speed this up a little bit more when I say I want to use, I actually just need 3 columns. So let's only query the 3 columns. Even faster, although it's less RAM usage, so it gets just better, right? And if I combine this together, both approaches use date and just raw SQL, I'm already almost 7 times faster. So what can I say? In the end, just after a couple of minutes, I was from 450 milliseconds to 90 milliseconds per request. It's a win, actually, for the environment and everybody, but it has, of course, some considerations which we need to talk probably afterwards, right? But how about the emissions now? So I used the green frame tool to get the emissions estimations. Almost 70 milligrams per call for the slow export, and 5 milligrams of Carbon for the fast export. That's 90% less emissions. Of course, now milligrams sounds a bit like, should I even care? But imagine how many of processes are running all the time on the world. And if we can manage to reduce the emissions by 90% just because of these little few operations I did here, then I think it's worth considering. Global IT has a share of 4% on the global greenhouse gas emissions, so it's not insignificant. This here is the freely available version of the green frame tool. It does not give me so much information. If I pay them a couple of bucks per month, then I will get this beautiful view. And what I found quite interesting is, of course, the CPU uses some energy, but according to their tool, the network traffic between the Laravel app container and the MySQL container was the biggest cause for energy consumption, and thus Carbon. I cannot really say how accurate that is, but at least it's an indicator, right? So when I look at the fast export, then we go down to 9 milliwatt hours here. So it's significantly less compared to the other one. This is because, yeah, we have significantly less data transfer between the containers. Again, I cannot really say how accurate the numbers are. For me, it's more important to get the relation between both approaches which I have. In the end, it's anyway some estimations. All right, so I'm almost done with my talk here. So basically, I think what this means for us, what we are doing right now is we are basically driving with our big SUV to the shop. We are doing some groceries and we drive back. But maybe I have planted some seed now here today. Yeah, of course, flowers. I like plants, I don't know. Maybe I planted some seeds here and there. Maybe that's not necessary all the time. I mean, everybody loves comfort, right? And this is why I think we are using things like Carbon or Laravel or such. But maybe it's sometimes time to step back again and yeah, do things a little bit smaller scale or a little bit simpler. To recap what we learned today or what I was talking about, yes, software does cause indirect emissions. We can measure, calculate, estimate them. We can reduce them. This probably needs some change in mindset though. And sustainable software has other benefits, like cost reduction. I didn't even talk about all the other things, like better performance is better for your customers. Think about SEO. I think SEO is still a thing nowadays. So all these kind of things, there's a lot more. And if you're interested in this topic, this is my little GitHub repository. It's just a link list where you can find a lot of resources about this topic. Let me know if this is interesting for you. And yeah, some shameless self-advertisement. I have a LinkedIn Learning course. It's in German only, but this is about green coding, the basics of green coding. So if you're interested to learn more about that, maybe give it a view when you have LinkedIn, of course. All right, that's it. Thanks very much for the attention. And if you like, I'm only on LinkedIn. I learned today that many people in PHP are on Mastodon. Probably I should go there. But so far, I'm only on LinkedIn, or you can reach me via good old mail. I'm happy to connect and wish you now a really, really nice evening with the socializing, some nice drinks. And yeah, thank you so much. Thank you. Sound problems will be solved in a second.
No questions? In the back, right in the back. I think we have some other mics.
For your talk, especially for the technical side of the sustainable development concepts. I have like another input, maybe not writing code at all, is also sustainable. So if you're in contact with your customers, not implementing a feature is also very sustainable. So it's not always about taking all the input and then implementing it, but also maybe giving like feedback and asking if the feature is really needed. And it's also about the development process. So agile development, implement, test, and only develop features that are actually used by the customer, because a feature that is not developed is the
this is actually a very good point, and you might have noticed that I put product design in one slide. This is exactly the point. So there you can do so much with the good UX. There are books about that, which I can only recommend, from Tim Frick, Sustainable Product Design or something like that. It is exactly about that topic. And also, again, if you have some leftover code in your code base, remove it. Maybe I have this as well in my code base. There are some tests which we keep running for I don't know how long, although the code is no longer used. So we just started cleaning up our code base because eventually it piles up. So removing things or not doing things is probably the best one which you can do.
And there's also a concept like deprivation testing. So you remove features from your application and then try to find out how your customers react. And then you find out if a feature is actually used. So
Yeah,
And yeah, there are a lot of aspects. Also, the purpose of your software. Somebody can wanted to implement a fleet management, but you can also advise them to maybe try to reduce the carbon footprint by not giving out cars, but maybe showing that there is like a connection via public transportation. So, and if you're in luck and have a contact to the customer, then you can also kind of influence this development into this direction. So it's not always about writing code.
Mm-hmm. Very good point. I like this idea. I will talk to our CPO next week and let's see what he thinks about that. But this is actually, since you said just deactivate the feature and see what happens, this is also for the infrastructure which I mentioned, turn off unused resources, right? There's really, which we call scream testing. So just disable the server and see who cries. This is how you can find out if a resource is still needed. And if nobody cries, yeah, well, what happened?
So,
yeah.
I mean,
yeah, but there it gets really complicated, right?
I know, yeah.
Side effects also, same why PHP Stan always checks the whole code base and not just the code we change, because there might be side effects. But yeah, it's a good point. All right, I think everybody else? Oh yeah, one
we
more.
have a question in the front.
Not actually a question, but a short comment regarding the changes in PHP 8.4. Besides the sprintf optimization, every new PHP version comes with other performance improvements. In fact, the upgrading guide and the PHP repository always lists some of them. So keep your PHP updated, and your code is going to get faster without you doing anything.
That's a very good point. Yeah, I should add this really to the list. Yeah, always keep it up to date. I mean, I'm not sure if this is really true for other programming languages, but for PHP 8.4, PHP, you can really see there are some diagrams that show that every version it gets better and better. So this is amazing work from the PHP community. Big applause to them, I would say, right?
So is there another question, one last question, perhaps for Carsten? If there is not, then we thank you again for your talk.
Welcome.
Happy to be updated about some new tools or developments in this area. And please stay seated, because we will switch the person who's standing behind the and have a quick wrap up.
Thank you.
That's it, guys. So, a big round of applause for all the speakers today. Okay. Again, you did an amazing job, like every year. Really appreciate it, and I think that everybody is still sitting here is a good sign. So, you're always welcome at our user group for meetups, and yeah, we will stay in contact, I guess. Also, thanks to the whole team organizing this event today. Especially, again, Sebastian, one of the Sebastians, the tall one, for hosting us and making a lot of technology possible here. So, please applause. And of course, thanks to our 9 sponsors, not 8, and 9 sponsors. Yeah, so without them, it would also not be possible to do some events like this. So of course, everything costs a bit of money, especially the food and badges and stuff like that. Regarding the badges, I would appreciate if you return the lanyards and the plastic stuff to us, so we don't have to buy it again next year. You can, of course, stick with the badge itself for your memories. Yeah, then we wanted just to announce our next meetup. So if you're around in Dresden, next meetup is on November 14th. and it's a special together with Dresden.js at Zalari. I think we already have one talk, and we are looking for a second one. So if someone is encouraged by this conference today to give a talk themselves, just hook us up and we will make something happen. And yeah, Anke has also something to announce.
Yes, if you like this location and want to get here again, in a couple of days, roughly a month, we have the NEOS Barcamp here, and you can still get some tickets. Just go to barcamp.neos.io and grab it. And then we have to thank you for coming here, because without you, we wouldn't have a developer day. And I hope all of you probably leave some space in, I think, around September, perhaps, around the same time next year, because I hope these organizing guys will just get such a great lineup as we had today for next year. So give yourself some applause for making some space in your calendars. So what's left to say? Yeah, I mentioned we will socialize downstairs in the courtyard. We have some music, but before that, we need your help to wrap everything up, to pack up, to make this conference room a boring conference room. And we need 5 to 8 people in the back who will be guided by the guys who just manage everything today. And the other helping hands to just grab the boxes when they are packed and take them downstairs. I think, Sebastian, you know where they should go. Yeah, he nods for everyone who's not looking in that direction. So thank you for being here. And
yeah, that's the dark side of community, you know. You have to help each other. So once again, thank you for being here today, and see you next year. And see you in the yard for our last supper, right?